Rolling. As he said, my name is Josiah Wannemacher, and I'm not necessarily from Lansing. I'm from Maine, but currently residing in Lansing for the past 2 years. Okay, but that's all the introduction you need about me personally. Let's just get to the subject matter. So, how many of you have ever heard of hydrotherapy? Yeah, it's what it means is pretty intuitive. Hydro, water, and then therapy, the use of helping or aiding the body, some kind of therapy for therapeutic purposes. So, how many of you have ever done hydrotherapy or used it for yourself? Yeah, everyone here. Have you ever taken a shower? I hope so. Well, that's a very wonderful and easy way to apply hydrotherapy to our bodies. So hydrotherapy, I have a clicker. That's pretty cool. I can use the clicker. So hydrotherapy is the use of water to prevent and to treat illnesses. And hydrotherapy, water comes with many benefits because it's abundant, right? It's physiologically active. It can affect the body. It can manipulate physiology. We're going to get into some of those details. It has a high heat capacity. We're going to break down that a little bit later. And a high heat conductivity. So all these wonderful things. And it's not physiologically reactive. So how many people know somebody that's allergic to water? Yeah, so it's pretty safe. You don't even have to worry about that or anything. So here we have a number of examples of people utilizing hydrotherapy. Water aerobics we see on the screen. So a guy in the middle there, nice cold water bath. We're going to get into some of those. A nice bathtub there for more therapeutic purposes. And then your own bathtub. My bathtub doesn't look as nice as that one. And then fomentations, cold and hot shower. We're going to get into all these details. But these are some examples of hydrotherapy or their applications. So the basic physiological principle that maybe some of you are familiar with, but we're going to really make it clear in all of our minds. So what are one of the ways hydrotherapy reacts or operates with the body? Well, it works with the vascular system. So the intrinsic effect of hot on blood vessels and the body is to increase metabolism, okay? Increase the rate at which the chemical processes take place in most biological systems, okay? So like even in non-biological systems, you have water. You start applying heat to that water. What do the water molecules start to do? They start to move faster and vibrate, and actually the entire volume of that water will get larger, okay? Because the molecules are moving faster and faster, pushing up against each other. So they increase the volume, all right? But when you freeze water, it starts to get slower and slower, and actually it actually increases volume again, increases in size just because of the hydrogen bonds begin to bind together, and yeah, okay, fun stuff. But increased metabolism, same with our body. Once we start increasing metabolism, increasing the rate at which the bacteria, cellular organisms are doing their chemical processes, okay? So, however, this is not necessarily true with muscle. Another way to portray that, the increasing of metabolism, the slowing down of metabolism is like why you put your food in a refrigerator. That's to slow down the bacteria, their metabolic processes so the food can last longer, right? Okay, but what's happening here is vasodilation in the heart. So muscle operates a little bit differently, okay? And you would think that when you apply heat to a muscle or a blood vessel, because there's 2 types of muscle, actually 3 types of muscle in the body. You have skeletal muscle, which attaches muscle to bone and enables us to move. And then you have smooth muscle surrounding our blood vessels, our intestine, and other organs, and then cardiac muscle, which is obviously surrounding our heart or involved with our heart. So muscle pretty much operates very similarly. So when we apply heat to muscle, it increases metabolism. No, it doesn't actually. It's the exception to the rule. I'm getting ahead of myself here. But it's the exception to the rule. It actually decreases metabolism. You can see this portrayed or exhibited by somebody. Have you ever shivered before? Yeah, when you're cold. And then there's a compensatory reaction to start contracting. So it's actually the opposite. So with most biological systems, heat increases metabolism except with muscle because there's a compensatory reaction. And then when it's a really hot Michigan day, if they exist, or at least in Alabama, it gets really hot and you just don't feel like doing anything because your body, you don't want to generate any excess heat. So, because whenever you have work, whenever you have energy being applied, you get heat. So your body's trying to not produce too much heat because you have a lot of external heat from the sun and your environment coming at you. You don't want to have to produce anymore because we want to stay at that nice body temperature, 37 degrees Celsius, right, or 98.6 degrees Fahrenheit. So we can utilize this physiologic understanding, these physiologic principles with hydrotherapy because we can manipulate the body's temperature with water. We're going to get into that more detail. But let's understand the concept of vasodilation and vasoconstriction here. So hot, applying to blood vessels, what does that do with our understanding so far? Relaxes the muscles, right? Well, it relaxes our skeletal muscle, and it relaxes the muscles surrounding our vascular system, the smooth muscle. So it relaxes them, and the lumen, the cavity within the blood vessel, gets larger. All right, so we're having increased blood flow to that area, wherever it's getting warm, wherever that vasodilation is seen. And then conversely, when we have the cold application, what's happening? It's constricting, exactly, we see here. And our body does this for a variety of reasons. We see in the picture to the far right here, the blood vessels on the right side are dilated. That's to actually bring body heat to the dermis and kind of expel excess heat. That's why when you're really hot, your skin is nice and red because you're trying to transmit the body heat from the core to the surface to have that radiate out into the atmosphere or into the environment. And then opposite is here. But we can manipulate that just by applying heat to the skin here, and we get that vasodilation. And then applying cold, we get on the left side that vasoconstriction. So you can augment circulation. You can do a little experiment at home, or even when you're washing your hands in the water, or your feet in this case. You can put your foot in some hot water and you'll actually see it turn red. Have you ever washed your hands in hot water? You've seen this, right? This is not new. I'm not making stuff up. And you put your feet in the cold water or your hand in the cold water, they start to turn a little bit more pale. That's what's happening. You're relaxing the blood vessels, so increasing the lumen or the diameter of the interior diameter, so more blood flow is coming to that area. All right, so you can increase circulation, increase the amount of blood coming to a certain area. That is pretty cool. So by appropriately using these two physiologic principles, it enables us to be able to circulate systemically or locally. All right? And why would we want to circulate the blood so much? Why is this so important? Why are we so fascinated with circulation? Well, the blood is vitally important for health. What does the blood contain? You guys know this intuitively. What does the blood have in it? Why is it essential for it to circulate? Yeah, oxygen, nutrients. I have it right here on the screen if you can see it. Glucose, fatty acids, amino acids. It's how nutrients, energy gets transmitted. It's the transportation system of the body. It's how everything goes around. Platelets, proteins, hormones, signaling hormones, building proteins, prostaglandins. I was speaking with someone earlier about arteriosclerosis, breaking down of that cartilage. Well, prostaglandins are essential for the building block of that collagen. So temperature regulation. If we're too warm, it's trying to divert the blood to the dermis and trying to have that heat transmit, radiate off of us in the form of sweating, and we'll get into that too. It losing a lot of heat, very efficient. And then when we're cold, well, constricting these blood vessels in the periphery and shunting it back to the core, trying to maintain our vital organs, all right? And much more. So very important, electrolytes, very important. And actually we see this in the Bible. Adon was mentioning this earlier. The life of the creature is truly in the blood, right? So we see here Leviticus 17:11, and really till the end of the chapter, it's what it's talking about here. But for the life of the flesh is in the blood. Then it says he's given it to us to make atonement, and beautiful. But the life of the creature is truly is in the blood. That's how everything's circulating. So if we don't have good circulation, then, or if we can't get life or blood to one part of the body, eventually, in time, depending on that organ or tissue, it's going to start experiencing some dysfunction or disease, all right? So So I love how, well, before we get to that part, so what do these conditions have in common? Heart disease, peripheral artery disease, vasoconstriction or constriction of the arteries in the periphery, atherosclerosis, just plaque buildup, arterial sclerosis, hardening of the blood vessels due to a variety of reasons, varicose veins, dysfunction of the valves within the veins, the one-way valves that keep the blood pumping in a circulatory motion towards back to our heart, into the vena cava, into the right atrium, right? So those can begin to dysfunction, and the blood, instead of continuing to go up in those one-way valves, like the lobster traps, it starts to dysfunction, and the blood actually will start to backflow through it. Wow, we could go a while on that. But just, dysfunction of those valves. Diabetes, the high sugar causes inflammation to the arteries directly. Obesity, just increased body weight, increased vascular pressure, okay? So harder for your heart to pump the blood all the way throughout your body. Raynaud's disease, constriction of the arteries, especially in the fingers and toes. Osteoarthritis, poor circulation to the cartilage in the joint. So that's actually another interesting one. So if you think about it, I was just speaking with someone earlier, same person that I mentioned earlier, or same conversation that I mentioned earlier. If you look at it, like, you never hear of osteoarthritis in like a 10-year-old or a 12-year-old, or really, it's like non-existent, maybe in some pathological circumstances, but it's usually later in life or midlife. And why it's associated then is because what also tends to diminish is our circulation. And we're not healing quite as rapidly as we once were. Well, our circulation is not quite as good as it once was. So our healing process is a little bit slowed. And to compound that issue, cartilage and tendons and ligaments, they're avascular, meaning they just don't have good blood, they don't have direct blood supply. They don't have blood vessels going to it directly. So they only get their nutrients through perfusion. As blood comes to that area, slowly leaches from the arteries into the extracellular fluid, and then eventually into that ligament or tendon or cartilage in this case, or into the synovial fluid, and then into the cartilage, right? So it's a very long process. That's why when someone an athlete just tears their Achilles tendon or lateral acromion ligament or something, it takes a while to heal, just because it's muscle. You know, when you're working out, you tear it all the time, micro tears, and it heals in a matter of days. You'll feel sore because of those micro tears just for a couple of days, and then it's healed because it's very vascular. It can heal very quickly. However, tendons, cartilage, ligaments are not very vascular, so they take a while to heal. So, and again, on the last thing, proteins, building block proteins, prostaglandins are key to the rebuilding of cartilage. So if you've got poor circulation, it's going to take a while for that cartilage to heal. And then on top of that, if you're doing some kind of activity that's wearing it down, then that's going to further compound it. So really, it's a poor circulation, and there's other factors as well. Every case is a little different. But again, so getting back to our list, nephritis. So what do all these conditions have in common? What is it? Inflammation. Yeah, they all have inflammation. But what else do they have in common? Like all disease, all chronic disease has inflammation in it somehow. So I would say circulation. They all are affected by or cause poor circulation, right? So peripheral arteries constricting, atherosclerosis, building up the plaque, limiting the amount of blood flow through there. Arterial sclerosis, hardening, narrowing, limiting circulation. I don't have, nephritis. That's a particularly dreadful one because as soon as so you have that increased circulation, all that pressure is going through your kidneys, the nephrons, the functional unit of your kidneys, the part that actually does the filtering, all that pressure, increased pressure going through those nephrons starts to damage them. It's like a tiny little filter here, and you put a fire hydrant through it. That's a lot of pressure. It starts to damage those nephrons and cause scar tissue to build up. Well, once you know it, the glomerular filtration rate, the rate at which blood is going through the nephrons, needs to stay at around a constant, okay? And when scar tissue starts to form, you damage the filter and not as much blood starts to go through. And then the kidneys secrete a substance, angiotensin, I forget, but the aldosterone angiotensin. renin-angiotensin-aldosterone system. And it causes the blood pressure to increase, further compounding the problem. So resulting in poor circulation and a variety of other things. So all these have poor circulation in common. They're either caused by or lead to poor circulation. All right, this was the quote I was getting to. Healthy blood, what does that say? Healthy blood and circulation are essential, very, very much so. I love this quote. In order to have good health, we must have good blood. Makes sense, right? We can't just have terrible blood and circulate that and expect to have health. We need to load the blood with our diet, with what we're eating, with what we're consuming, and with our lifestyle, right? And then we need to be able to circulate that. So, good health. For blood is the current of life. This was written many years ago, before we have the understanding that we have today. It repairs, wastes, and nourishes the body. When supplied with the proper food elements, and when cleansed and vitalized by contact with pure air, it carries life and vigor to every part of the system. The more perfect the circulation, the better will this work be accomplished. And again, healthful living. Perfect health depends upon perfect circulation. Okay? So, how well can we actually augment circulation? This is a fascinating study done on, I have a man here, but the study was actually done on several or many women. But they did just applied a fomentation to the low back, one fomentation to the low back, and it increased the circulation locally to that area. We'll get into what is a fomentation in a little bit. I got you. Low back, it's increasing circulation to that local area by 156%. That's pretty incredible. And the upper extremities significantly. All right. And then again, a warm bath. A 30-minute warm bath improves blood fluidity by decreasing the viscosity of the blood. Adon mentioned that word viscosity. It's just the thickness of the blood. It's like molasses or honey. That's very viscous. It's very thick. But water flows really nicely, and that's not so viscous or less viscous, okay? So we want blood that flows more like honey, right? No. That's very difficult for the heart to pump. Imagine someone with very viscous blood. Their heart has to work very hard to be able to pump that through the whole vascular system. That's a lot of work. If you have a 1 horsepower pump trying to pump a huge quantity of water, what's going to happen to the pump? This is going to burn out eventually. It's too much work, okay? And again, so this is neat anatomical understanding. The dermis can hold 25 to 30% of the entire blood volume. This becomes significant when you start thinking about applying hot and cold to the body. You have an immense capacity to be able to manipulate the amount of circulation, entire circulation, okay? So, just the dermis. So if you were to get in a hot tub and you load your dermis up with blood, that's probably even a little bit more than 30% of the entire blood volume. And then think about jumping into a cold tub, constricting all those blood vessels. Well, you're really circulating that blood, reoxygenating it. Okay, cool stuff. We're getting. So, hydrotherapy. With all this manipulating of cardiac function and circulation, is it safe for people with cardiac disease? What am I trying to say? Cardiopulmonary disease. Well, yes. According to this 104-degree Fahrenheit warm water immersion study conducted on men with clinically stable coronary artery disease. That's what I was trying to say. This study showed this, according to that study, it was and found to be beneficial. And then another study showed that sauna therapy with high humidity, so near 100% humidity in the air, was safe for patients with stable heart conditions such as hypertension, coronary disease, or stable controlled chronic heart failure. We're going to find that it's even more beneficial than just being safe. Hydrotherapy, is it safe for those with cardiovascular disease? Again, even a simple warm foot bath has been proven to improve coronary flow reserve with no adverse effects on patients with coronary artery disease. So even with all this manipulation in blood flow and impacting the heart, yes, it is safe for those with cardiac issues. Okay, So this is getting back to that metabolism question. This is really cool. Okay, so metabolism, what is it? It's basically, we went over it, it's all the chemical processes that occur within a living organism to maintain, to sustain life, okay? So with every increase in body temperature, with every 1 degree Celsius increase in body temperature, metabolism is increased 10 to 12.5%. Wow, yeah. So metabolism is, and we often think about it as burning calories, taking food and turning it into energy in the mitochondria, as Adon was saying, making that into adenosine triphosphate, usable energy for contracting muscles, other things. So, but we can increase our metabolism just by going into a hot tub. And this is really fascinating because if you think about a fever, has anyone had a fever before here? I should hope so, yeah. Fevers are a wonderful thing, just we need to control them. Anyway, in a fever, you typically elevate your temperature how much, would you say? How many degrees do you elevate it? So 98.6 is our normal, and then typical, somebody might have a fever of 101, 2, 3, 4 if it's a really intense one, or you're doing an artificial fever. Well, that's like 4 degrees, right? That's 40% increase in metabolism. That's pretty significant. Okay, so, well, that's Fahrenheit. We're doing that, and Celsius is like 1.8. So it would be 37 in Celsius is body temperature, and you're going to 40 degrees is 104 in Celsius. 40 degrees Celsius is 104 Fahrenheit. So you're still, if you could make it up to 104, that's still 40% increase in metabolism. Still significant, which is fascinating. And this becomes, just hold it all together and it's going to be really beautiful. All right, muscle, the exception to the rule, we kind of touched on this earlier. Hot decreases metabolism for both skeletal and smooth muscle. The opposite of what typically takes place in most biological systems. Right? Remember, just think of a hot day. You don't really feel like working because you don't want to generate heat. You don't want your body to overheat. But either that or you're just lazy and you don't want to work that day. When cold increases metabolism in the muscle by a compensatory reflex, a fusomotor shivering component. All right. Another aspect of muscle and fascia and blood, actually, that they're finding is that it's thixotropic. That's just a fancy physics term for meaning something that becomes less viscous when energy is applied to it. Okay, whether thermal or mechanical energy. Have any of you done the experiment with cornstarch and water? You mix it up and then you punch it and it's almost like solid and then you just glide right into it? Nobody here? You have, okay, yeah. Homeschooled or homeschool? Fantastic, yep, I was too. That's the kind of experiments we do. Yeah, so you punch it, it's solid, and then it melts, and you go right into it, right? So that's thixotropic, solid, and then it flows. Our muscle and our fascia are a similar way. Fascia, it's a connective tissue that surrounds and holds every organ in place. So the reason why your kidneys don't float around and stuff, they're attached via vessels, but also fascia is what's holding it in its orientation. Your intestine and large intestine is all connected with fascia. The peritoneum, pericardium, that's all fascia. You have epimysium, that's fascia wrapping around individual muscle fibers. Fascia is important, okay? And when we get adhesions or scars, scar tissue, that's fascia too, binding and adhesing, all right? Well, when we apply energy to that fascia, at first the tensile strength of the fascia is strong, but we continue that energy and then it kind of melts and breaks apart. Well, muscle is a similar way. So that's why applying a hot fomentation, I promise you we'll get to the fomentation. A hot fomentation relaxes the muscles. So apply the heat to the muscle and it causes it to relax. Ready? Both because of the thixotropic aspect of muscle, but also because of the intrinsic effect of heat on muscle. Muscle doesn't want to have to work, and it just relaxes because it's a hot summer day, right? Relaxes. So that's why putting heat on a low back pain or somewhere you've got a tight muscle is very beneficial for relaxing and decreasing the pain there, okay? So that's what that is. Oh, I'm going to read it from here. Viscosity decreases by up to a factor of 10. That's pretty cool. All right. Vascular compliance. Blood pressure is a robust indicator or predictor of future incidences of stroke, coronary heart disease, heart attack, heart failure, cardiovascular related diseases. Actually, the CDC did a study a while back, not too long, several years ago, but not like 19s, still 2000s, where they looked at the global burden of disease. What is the actual cause of death? What is the leading actual cause of death? Yeah, I got to back up real quick. So there's two types of causes of death. There's cause of death, which we think of heart disease. What did he die of? Cancer. What did he die of? Cerebral vascular accident or something. But then there's the actual causes of death, which is what caused the cause of death. So the leading cause of death in America is heart disease or cancer. They neck to neck almost. Okay. But what causes the heart disease? Oh, the high-fat diet or high-sugar diet or lifestyle, right? So the actual cause of death. So the CDC did this study and wanted to find what was the biggest actual cause of death. And what they found was too much sodium intake and too little fruit intake, which is interesting because they operate together. I wasn't intending on saying this, but I've already gone this far. So what happens is sodium, as we kind of know, increases blood pressure, and how it does that is by, well, a number of ways, but one of the ways is by diminishing the activity of the enzyme superoxide dismutase, which is a profound neutralizer of free radicals. All right, so free radicals, or he could tell you more about that, but instigate inflammation and chronic inflammation. So if you have a lot of free radicals running around, they cause a lot of oxidative stress, you could say, okay? And so salt decreases the enzyme that neutralizes free radicals, all right? Well, fruit, high in vitamin C, increases the activity of superoxide dismutase. So you can see how they got to these two actual causes of death. Too much salt, too little fruit. Because this is causing inflammation and oxidative stress to go through the roof, and the thing that mediates that is not being consumed, vitamin C and fruits and vegetables for a variety of other compounds and components and other mechanisms, okay? So, and why that's so important is because circulation. Both of those are affecting circulation. Too much salt, more inflammation, more oxidative stress. Too little, not able to reduce that oxidative stress, so you get the inflammation of the blood vessels. Circulation is so important because we just saw the list of diseases. If you have high blood pressure, it's going to affect every single organ in your body, because every single organ in your body needs blood. All right? So it's going to, in the case of the kidneys, too much blood pressure causes the nephrons to start dysfunctioning, and then that's a cyclical cycle, and just impaired nephron function causes increase in blood pressure, and it just gets worse, spirals down. Anyway, so hypertension or high blood pressure that's why it's such a robust measure of all these, especially cerebrovascular and cardiovascular related deaths. So another aspect, so the endothelium. Endothelial cells are the cells that line the inside of your blood vessels, okay? But they're cool because they actually secrete different, what does it say there? Different substances, just uses the general term substances that regulate vasodilation and vasoconstriction. The one here, endothelial cells will actually secrete nitric oxide, which is a vasodilator, all right? So endothelial cells, they secrete nitric oxide. Actually, when I was working on the ambulance, we would give something called nitroglycerin to somebody who was having chest pain, right? Similar mechanism in a way if you look at it, but nitric oxide, a vasodilator. Well, our endothelial cells produce this nitric oxide as well, okay? And so that's why just doing this, when you manipulate, when you move, when you massage, or when you move endothelial cells, they actually secrete this stuff. So just when you're rubbing and touching your skin like this, it causes that substance to start being released. That's why, probably, well, I won't get into that yet. Yeah, but like even massage, that's one of the mechanisms why it increases circulation, because you're manipulating those endothelial cells. Actually, ultraviolet light actually will cause nitric oxide to be released, which is why being out in the sun is good for people with high blood pressure, because it decreases blood pressure. Probably other mechanisms go into it as well, mental components, and just being out in the fresh air. But the ultraviolet light is known to directly increase nitric oxide release. Okay, also, endothelial dysfunction is characterized by decreased secretion of these vasodilators and increased in secretion of vasoconstrictors. Okay. End-stage heart failure. This one was particularly interesting. In this study, patients with cardiomyopathy with refractory, if anybody wants the references, you can't quite see them here. If you want to look them up, I can send you the PowerPoint or somehow, but I thought I had them up high enough. But anyway, in this study, patients with cardiomyopathy were with refractory chronic congestive heart failure who were awaiting heart transplants. They were done. They were just waiting for a donor, okay? The grade of mitral regurgitation, they were just in a warm steam foot bath, okay? That's all they did, just a warm steam foot bath with people with end-stage heart failure, waiting transplant. So they said, all right, we'll take these guys. What else bad can happen? Let's try it, right? So they did a study, and they put their feet in warm steam foot bath. What happened? The grade of mitral regurgitation tended to decrease. Endothelial function measured by arterial tonometry, just know it's a good thing, significantly increased. Thus, steam foot bath therapy is safe and beneficial for patients with end-stage heart failure awaiting heart transplant. So the people at the end of the journey is, heart, what else can you do? We just need a transplant, all right? Well, they found that it was beneficial to do a simple hot foot bath. Here it was steam. They didn't try just putting the feet in water. They went straight to the steam. But I think it would have a similar effect or even a more greater effect just because you have more contact with the moisture, and we'll get into that heat conductivity and heat capacity a little bit later. But I think you'd even have more of effect, or at least the same effect, with just a hot foot bath. Okay, so right here, water has a high specific heat and high heat capacity. High specific heat capacity and heat conductivity. What that essentially means, a high specific heat capacity, that's just the amount of energy needed to raise, no, that's not a good way to say it. I wrote that, that's not right. Well, I mean, it's right, but there's a better way. So specific heat is the amount of energy that it takes specific heat is the amount of energy that can be stored in a substance. So think of it this way. Paraffin wax. Has anyone done a paraffin wax dip? Yeah. Okay. So the amount of energy that it takes to melt wax is not very much, right? So you can put your hand in wax that's like 115, 120 degrees, or even 25 degrees, no problem. But if you try putting your hand in water that's 125 degrees, that's going to burn you. That's going to hurt pretty bad. But paraffin wax, no problem. Okay, so paraffin wax doesn't hold a lot of energy. It doesn't take a lot of energy for it to become less viscous or to melt. And also, it doesn't have a high heat conductivity. High heat conductivity just means the amount of, how quickly heat energy, thermal energy, can be transmitted from one material to another, all right? So you ever walked on a rug and then a tile floor? So you're walking barefoot on a rug and then you go onto the floor of tile. The rug feels warm or not cold, and then you walk on the tile, it's pretty cold, right? It's not that the tile's colder, typically, generally speaking. It could be because it's taking the cold from the ground and radiating it right up through the tile. But typically speaking, if you were to put a thermometer on the tile and a thermometer on the rug, they'd be the same temperature. It's just that the conductivity is so much higher in the tile, Okay, so it's the same temperature, the rug and the tile, but the conductivity is higher. So the rate amount of thermal energy transferred. All right, so specific heat, the amount of energy that can be stored in the substance, and conductivity is the amount of heat that can be transferred. Now this, water has a high both of these. So water can store a lot of energy and it can transfer a lot of energy. This has incredible implications when we're talking about hydrotherapy and manipulating, augmenting body temperature. So heat shock proteins, this is neat. So heat shock proteins activate receptors of the innate immune system. So they instigate and initiate the immune system function. They act as internal chaperones and provide multiple cytoprotective maintenance services of normal cells through their expression. Heat shock proteins also provide functions essential for maintaining protein homeostasis. Homeostasis is just that balance of the middle of health, maintaining function. So an example of protein homeostasis was making sure proteins are functioning correctly, right? Making sure proteins are doing their job. A couple things need to be appropriate for proteins to function well. They need to be in the right, they need to have the right amino acid sequence, right? And the 3 amino acid sequence. But also they need to be folded correctly, okay? And what heat shock proteins do is they go around and say, okay, is this, this protein right here, a mutation happened where amino acids got flipped or an amino acid got taken out or a frame shift took place, something happened. We can correct that or we'll cause it, we'll say this protein should not be here anymore and we'll instigate it to do apoptosis, programmed cellular death, or we'll repair it. And also proteins can, due to thermal stress or environmental stress or oxidative stress, the folding of that protein, kind of like an origami airplane, if you fold the airplane, it can fly, right? If you fly it right. But if you unfold it in a certain way and you try to throw it, or you unfold one of the wings, will it fly very well? No, it won't function right. So same thing with proteins. Proteins need to be folded. They need to have the right amino acid sequence, right? Sequence of amino acids to make the protein, but also then they need to be folded correctly, like a nice origami paper airplane. And if that protein is not folded correctly, it won't do the job. Just like the paper airplane won't fly. I've never used that paper airplane illustration. It's a good one. I'm going to have to keep that one. Okay, so it's not going to function. So heat shock proteins go and they look for those proteins and say, this one's not functioning right. Let's either fold it again. It's a master origamiist, can I say? Okay, and refolds it. All right, or it says it's too far gone. We're just gonna let this one go. But the thing is it detects those and it says, okay, this one has a mutation. Let's get rid of it or let's repair it. This one's not folding correctly. Let's get rid of it or let's repair it. That's pretty sweet. So anything we can do to increase heat shock protein would be amazing if only we could manipulate heat shock proteins. Heat shock proteins protect against pathological expressions of transforming mutations, and these mutations could go on and lead to cancer. Heat shock proteins are upregulated under conditions of cellular stress and protect cells from severe damage and premature death. So you have an environment with increased oxidative stress or whatever kind of chemical stress or even thermal stress. The proteins are going to break down, wear out. Heat shock proteins are looking for those and say, you're getting tired, let me fix you up. Okay, keep going. So they're cellular maintenance. Okay, excellent. Well, look at this. Heat shock proteins and hyperthermic, that's supposed to be sorry, I don't know, I miss, that's hyperthermic conditions. So heat shock proteins are presented on tumor cells in hyperthermic conditions where they signal to T lymphocytes to be more cytotoxic towards that tumor. So you have a tumor, and when that body or that tumor is exposed to hyperthermic situation, heat shock proteins find that tumor and say, well, this tumor is not supposed to be here, and they bind to the membrane of that tumor, and they instigate that inflammatory or that immune system response, and they get those T lymphocytes to become cytotoxic to that tumor and destroy that tumor. That's pretty incredible. Humans are induced to make heat shock proteins when the temperature is raised to several degrees above their normal temperature, like 37 degrees Celsius, that's our normal temperature, but several degrees above that would be 41 to 42. That's probably 102 degrees, 103 degrees, in that range. Well, what's a fever? It's in that range. That's pretty cool. So the level at which we need to get our body temperature to be able to have the benefits of these heat shock proteins, which are many, is not that far away. Wow. All right. So dysfunctional proteins and disordered proteins. Just to give you an idea of how important the correct folding of proteins are, has anyone ever heard of the condition cystic fibrosis? Okay. It's a really terrible disease, and it's caused by dysfunction, but dysfunction in a previous generation, or it's a mutation of a protein or a gene in the DNA, which causes the misfolding of a protein and increase mucus production, and they can't breathe very well, a variety of things. But that's just due to the protein the information was not in there to tell the protein how to fold correctly. And so it's pretty rough. There's not much you can do for it that we know of now. But anyway, so dysfunctional and disordered proteins are a common feature in cardiovascular disease. Dysfunctional and disordered proteins aggregate and clump together. Dr. Sanchez was talking about this earlier. They can aggregate and clump together. Dysfunctional and disordered proteins can lead to mutations and cancer. Dysfunctional and disordered proteins aren't carrying out their purpose. Just like if the airplane isn't folded right, it's not going to be able to fly and glide through the air. Unless it's an origami ball or origami boulder, which fly pretty well. Okay. So aggregation and clumping are strongly implicated in the pathogenesis of neurodegenerative diseases such as Alzheimer's disease and Parkinson's disease. How many people know somebody who has Alzheimer's or Parkinson's disease? Almost everyone in here. So really, it would be beneficial to know something that can help these things, right? Well, there's a lot of things that can help, but not one of the least of them is hydrotherapy. So we can aid in helping these proteins not to aggregate and clump together. You've heard of beta amyloid plaques, right? Okay, maybe not. Another lecture for another time. Okay, so Alzheimer's and Parkinson's are associated with misfolding and clumping together of proteins. Speaking of brain health, we were just talking about Alzheimer's and Parkinson's. Warm water immersion bath was beneficial in maintaining brain function, homeostasis, by increasing the concentration of brain-derived neurotrophic factor and neuron-inducing factor, and reducing the concentration of cortisol. What is cortisol associated with? Stress, right. Well, that's good. We're reducing cortisol. And brain-derived neurotrophic factor, what does that do? It helps to repair and actually create new neurons in our brain. But it helps to repair neurons, so that's beneficial. Okay. Cold water, more on brain health. Cold water is known to activate the sympathetic nervous system. So Adon was speaking negatively of the sympathetic, well, not negatively, just if it's continued for a long period of time, overstimulation of that sympathetic nervous system, then that's bad. But we're not continuing it for a long period of time. We're just short spurts. So cold is known to activate the sympathetic nervous system and increase the blood levels of beta endorphins and noradrenaline. What is beta endorphins? Heard of these? It's a good thing. They're pain-reducing substances. Cold showers sends an overwhelming amount of electrical impulses from the peripheral nerve endings to the brain. Our skin has a lot of receptors for temperature, all right? And so when we stimulate them, when we put the whole body in a cold, moist environment, then we're sending a lot of electrical impulses to the brain, overriding a couple things, overriding the gate control theory of pain, and also just a flood of new chemicals, so it's kind of distracting the body from whatever other pain you have. And it results in an antidepressive effect. I was just speaking with a doctor that just visited Weimar Institute, or is it Weimar Institute, or is it, what is it? Weimar Lifestyle Center, or Weimar, anyway, we've heard of it. What is it? Yeah, but it's the Lifestyle Center. It's just Weimar Lifestyle. Okay, anyway. And Dr. Neil Nettily, he used to practice just with dietary measures and lifestyle counseling, right? And mental health coaching, that kind of stuff. But then he discovered that hydrotherapy has an incredible effect on the mind, on the brain function. And when he started adding cold hydrotherapy, cryotherapy, just using cold in an effort to have a therapeutic effect, when he started using cryotherapy, he saw a dramatic increase in his patients' well-being, in their mental health status, in their brain function. So he was already doing a wonderful thing with diet and mental health counseling, all these things, but then he saw a dramatic increase when he started doing the hydrotherapy, which is really neat. And here's a mechanism for that. So cold water exposure significantly increases activity of the hypothalamic pituitary adrenal axis or system. Repeated cold exposure helps to restore its normal function in the chronic fatigue syndrome, and at the very least increase the net HPA, or hypothalamic pituitary adrenal system. All right, daily brief cold stress can increase both numbers and activities of peripheral cytotoxic T lymphocytes and natural killer cells, both involved in the immune system. White blood cells, increasing white blood cell count. The major effectors of the adaptive, so cyto T lymphocytes and natural killer cells are major effectors of adaptive and innate tumor immunity and immune system. So again, cold stress-induced analgesia might be mediated by increased production of opioid peptide beta endorphins. We talked about that in another study previous to this one. It's just beta endorphins, they reduce pain. And actually, you've done this with ice massage or when you sprain your ankle to reduce the inflammation, yes, but also you're working on those beta endorphins in that area in the brain. So acting as a natural pain reducer. Cold water exposure. After repeat cold exposure, there is an increase in immune system. We just saw that earlier, but another study. Increase in immune system function, specifically leukocytes, granulocytes, circulating levels of interleukin-6 and interleukin. Okay, so in this case, when it says interleukin-6, that's a pro-inflammatory molecule. But also what they found was an increase in interleukin-10 as well, which mediates that inflammation, is a opposite of pro-inflammatory, anti-inflammatory molecule. All right, so cold water exposure increases those white blood cells, interleukin-6, and natural killer cells and their activity. Leukocytes, granulocytes, and monocytes responses were augmented or increased by pre-treatment with exercise in water. And thus, acute cold exposure has immune-stimulating effects, especially when combined with exercise. Wow, we can increase immunity, increase the immune system function with cold exposure. And we can help that with doing a little exercise. And how they did this was they did exercise in a cold pool, a little bit of water aerobics for a few minutes, and then they got in a cold shower for another few minutes, and then they checked these levels. Fascinating stuff. FOXO3 proteins are really associated with longevity. Ready? Play an important role in human lifespan and healthy aging. FOXO3 proteins regulate a vast number of genes that combat elements of cellular aging, such as damage to DNA, right? Proteins, and lipids, and a loss of stem cell function. Wow, they help to combat degradation of those things. Increase the production of genes that regulate DNA. Wow. Repair tumor suppression, stem cell function, immune function, and protein aggregation to further mediate the deleterious effects of aging. FOXO3 proteins. Wow. I wish there was a way for us to augment or increase the work of these FOXO3 proteins. Maybe there is. Stay tuned. So FOXO3 proteins also participate in autophagy. But when autophagic mechanisms are disturbed, FOXO3 proteins confer cellular sensitization to apoptosis, a type of programmed cell death. So autophagy is when the body sees a part of the cell inside that is not functioning correctly, and it either gets rid of it or repairs it, similar to the heat shock protein. So it's participating in that cellular maintenance. Okay, well, following heat stress, we have a way to be able to enhance these proteins. I just want to take a step back. There's no medication that can enhance heat shock proteins. Nothing that can stimulate heat shock proteins. There's no medication that can stimulate FOXO3 proteins as of now. The CDC right now is trying to get a vaccine to be able to stimulate heat shock proteins. And I don't know about FOXO3, but they're working on it. But why would you need a vaccine when you can just do some exercise? When you can just do some cold from hydrotherapy? Wow, seems a lot more less invasive and easier to me. Anyway, we can actually affect these FOXO3 proteins too. Following heat stress, so just a hot tub or a hot shower, the FOXO3 proteins form a complex with sirtuin-1, an enzyme that influences aging and longevity via multiple molecular pathways. Sirtuins regulate a variety of metabolic processes, including release of insulin, mobilization of lipids, a response to stress, and modulation of lifespan. Sirtuin-1 enhances FOXO3's resistance to oxidative stress. Enhance their resistance to oxidative stress. Wow. And its ability to induce cell cycle arrest. But it also inhibits FOXO3's ability to induce apoptosis, shifting FOXO3 activities away from cell death and towards stress resistance. So it wants to build up the resiliency of cells rather than just immediately causing those cells to commit apoptosis. So warm water bath for type 2 diabetics. This is the last study we're gonna show on just the physiologic effects of hydrotherapy on the body, and then we're going to get into hopefully a little bit more practical application. Warm water baths for type 2 diabetics. In this study, it was a small study, but all the physiologic responses were beneficial. Okay, so all measured biomarkers improved in this study. One patient had to lower his insulin by 18% to prevent hypoglycemia. All right. The average weight loss was 2 pounds. The average fasting blood glucose level dropped 23 points, and their glycosylated hemoglobin levels decreased. Nothing else changed. They didn't change their diet. They didn't change their exercise routine. They just said, we want you to soak in a bathtub for 3 weeks, 4 or 5 days a week. All right? And that hot tub was 100, and I think it was 1 degrees. Let me just look at right here. Oh, it was 41 degrees Celsius, so that's going to be like 102 degrees, somewhere in that area. Not incredibly warm, just a nice hot tub. That's all they did, just soak in a hot tub for 3 weeks, 4 to 5 days a week. And their insulin levels, their insulin requirement decreased. Wow, okay. And I mean, we know that diet and exercise can help with diabetes, but just something that passive. Huh. All right. So, hot foot bath. Hot foot bath reduces, I'm just going to talk about a hot foot bath. So, based on our physiologic understanding of hydrotherapy thus far, when we sit down and we put our feet in hot water, what's taking place to the vasculature in our blood vessels? Vasodilation, they're relaxing those muscles. Warm, hot Alabama day or Michigan day. I don't want to generate any body heat. Relax, okay? So increase blood flow to that area. We're increasing the lumen diameter, so there's more volume in that area. We're increasing the amount of blood in that area and the amount of nutrient transfer into the extracellular area, okay? So that's cool, increasing circulation to the feet, all right? But also, if we're having a headache, specifically maybe a pressure headache, many headaches are caused by just congestion of blood in the brain, in the cerebral cavity. So if we dilate the blood, the arteries and the veins in our feet, there's a fixed amount of blood in our body. So if we divert blood to the feet, it's not like there's the same quantity of blood in the head. No, it's actually pulls some of that blood away from the head and into the feet, decongesting the head, decongesting the brain, decongesting the pressure in the decreasing the intracranial pressure, you could say. So that's why just putting your feet in a hot foot bath works for so many headaches, because many of them are pressure headaches. Now, it doesn't work so well for tension headaches. Tension headaches are just due to tension, obviously. We hold stress in our upper trapezius muscles here, right? Those upper trapezius muscles attached to the scalenes, the occipitalis muscles, and then that occipitalis attaches to a fascia called the aponeurosis on top of our skull, which attaches to the frontalis muscle right here. And so if this muscle's tight, it pulls on these muscles, which pull on the aponeurosis fascia, which pull everything and just compresses the skull. So imagine, all these people, so tight. Oh man, imagine their poor brain. Obviously they have a headache. It's so tight. So in that case, what you could do is apply a fomentation. I will get to the fomentation. A fomentation to those trapezius and lowers, because they're thixotropic, it decreases the viscosity of the fascia and it lengthens the muscle there, relaxes the muscle. So in the case of a tension headache, you maybe want to put a hot pad or fomentation on the shoulders. In the case of a pressure headache, put your feet in hot water. Beautiful. Okay. And it also reduces fever, since it causes the circulation of white blood cells to increase. Hot foot bath also can combat a cold, headache. It can also help with headaches, as we just mentioned, or any congestion of the head, the chest, or the pelvic organs. In the case of menstrual difficulties, it can open up the totally blocked, this is exact Agatha's words right here, can open up the totally blocked nasal passages of the person in about 5 minutes. That's what she claims. I think it maybe sometimes takes a little longer in my experience. But by the way, Agatha Thrash is founder of Uchee Pines, and she was a very skilled pathologist and very renowned and respected. But yeah. And so when you're doing this hot foot bath, you want to have a basin of water about 110 to 115 degrees, so pretty warm. Now, if somebody can't make it up to there, initially, if you were to just put your feet right now in that, you'd be like, whoa, that's hot. But if you start at maybe 100 degrees and work up till you get to 110, 15, you can definitely get there. Now, you want to be careful with people with any kind of sensation impairment. So neuropathy, impaired function, impaired ability to be able to feel thermal extremes, or leprosy, as we just heard in the sermon, the deadening of the nerves due to a lepromyobacterium that kind of infects the nerves and causes poor sensation. They can put their hand right on the burner and they don't even feel like their hand's on the burner, and then, like Adan was saying, until they start smelling the flesh burning. Oh, my hand's on the burner. Oh, so pain is a good thing. We want to be able to take our hand off of. Well, people with neuropathy, they can't sense that the water is hot very well because, well, many times it's due to blood sugar being elevated chronically in the blood, causing inflammation to the arteries, which decreases circulation to the nerves, which decreases the nerve's ability to function, which decreases the ability to feel pain. So that's why you want to be careful with neuropathy, and just maybe don't do as extreme of temperature. And you want to do this treatment for about 10 to 30 minutes, 20 to 30 minutes. I encourage you to try this. When you have a headache, you can do both at the same time a little bit. Maybe just do the foot bath and then try it. And if that doesn't work, put a warm towel on your back. Okay, contrast shower. Wow. Contrast shower, increased circulation. So contrast shower, what is it? You sit in your shower for 3 minutes or stand in your shower for 3 minutes of hot, nice warm water. What's happening there? Vasodilation, right. I forgot to mention on the hot foot bath, before you end your hot foot bath, you want to end by pouring cold over your feet. And that's going to do what? Vasoconstrict. So you don't want to leave the blood in that area. You don't want to have it pooling there. You want to push it back up, recirculate it through. So same thing here. So you vasodilate for 3 to 4 minutes in the nice hot shower. And then you switch to the dreaded cold, right? For at least 30 seconds to a minute. And that's very stimulating and invigorating. If you've ever done it, you know. So this increases circulation, obviously. That vasodilation, vasoconstriction, removes toxins, stimulates the immune systems for mechanisms and that we have shown earlier via the studies, speeds up the healing process. I didn't say this very clearly, but if you've got a sprained ankle, after the initial 24 hours of applying ice, reducing the inflammation, reducing the levels of histamine in that area, all right, you want to start doing hot and cold. Why? Because the tissue that broke, the ligaments, in the case of a sprain, the ligaments that broke, you want to get new nutrients to that area, new prostaglandins, new proteins, more oxygen, more everything to that area. So we can put our foot in hot water and then in cold water. 3 minutes hot, 3 to 4 minutes hot, and then 30 seconds to a minute cold. That's augmenting circulation, increasing nutrient concentration in that area. And then fomentations. Fomentations are essentially, in PT, physical therapy and orthopedic practices, they have special, like ceramic or sand or other substances or thick wool, fomentations, but they put in a hydroculator. Has anyone had physical therapy before where they've done that? They use fomentations? Yeah, they put them in a hydroculator, just heat up the water, and that heats up the pad, and then they take that out, put it in a towel, and put it on your back. Well, we don't need all that fancy instrumentation. We can just use a towel, like a big bath towel, get that wet, wring it out, fold it nicely, and then wring it out, and then put it in the microwave for a few minutes. And then when you take it out, it's going to be pretty warm. You'll take that towel, put it inside of a dry towel, just so you're not in contact with that direct hot towel, because that'll burn you. And then you can place that right on your back. So that's a fomentation. And the reason why fomentations are superior to just a hot pad, an electric hot pad, is because of its moist heat. All right? Moist heat is important because, remember, the physics aspect of this lecture is because it has a high heat conductivity. Water has a high heat conductivity. It's able to transmit a lot of thermal energy into another substance, into your body, into your muscles in this case. So we apply that fomentation on the back. If you have backache or tension, pain, those paraspinals right here, the thoracolumbar fascia in this area is just tight because we're in this position too long. These are chronically tight, Well, apply that fomentation. It's just going to melt that fascia, relax those paraspinal muscles. Fantastic, good stuff. That's what a fomentation is. Now you can apply the fomentation wherever you'd like. If you've got rotator cuff issues, you can do a fomentation over your shoulder. All right, and you want to increase the healing process, increase the rehabilitative process or time. You apply that fomentation there, increase in circulation, increase nutrient density. All right, take it off, get a cold towel, put in some ice, rub it off, and then just rub your shoulder with it. That's increasing circulation of that area. So now that you understand the principles, you can take it and apply it wherever you'd like. Okay? Now, you see here, the patient here has a fomentation on the back. He's laying on a fomentation, but also he's got one on his chest. They use these with excellent success for actually, John Harvey Kellogg used it very much for things like pneumonia and other bacterial or viral issues. Yeah, in Uchee Pines, I remember I had a couple guests with pneumonia, and we did fomentations, and with very good success with that. Any bacterial or viral infections of the pulmonary system, very good for that, because you're bringing the blood flow to that area. You see he has a hot foot bath associated with this treatment. Now that's just there to increase the temperature, to increase the body temperature. Now, when we increase the body temperature, we are actually stimulating those heat shock proteins if we can get it high enough, and those FOXO3 proteins. But actually, it turns out that temperature is the signal for the white blood cells. The white blood cells are kind of stored, are housed in the lymph nodes and in the fascia, what they're starting to find out, but predominantly in the lymph nodes. And when you elevate the temperature high enough, like 102 degrees Fahrenheit of fever, it says, oh, we've got an infection going on. Let's call the army. Let's call the army reserves or into the circulation. All right? So that's the signal for the body. So what we're trying to do here is we're trying to send the signal for the army reserves, the white blood cells, to come out into circulation, and then we're localizing the battlegrounds to the lungs with the fomentation. So that's that. Utilizing this, fever, same principles being utilized, hot bath or hyperthermia bath. What's happening here is you're creating an artificial fever. So sometimes people are too weak to even elevate their body temperature. People with cancer, or just they run out of energy. They can't elevate their own body temperature. They want to. The body's trying to create a fever, but they can't. Well, we can help them with doing an artificial bath. Okay? Or even you can help yourself. If you're sick, you can create an artificial fever. Get in your own bathtub and do that. And what's happening here is, again, you're stimulating those heat shock proteins, but also you're sending the signal to the white blood cells that are in the lymph nodes that are just kind of there for they're on call. We have the Coast Guard, not the Coast Guard. What is the Army Reserve? That's what I'm trying to say. The Army Reserve, they're in the lymph nodes, and the signal that calls them out is temperature. All right? Actually, what happens in the case of a fever, when your body's having a fever, the hypothalamus, an area in the brain, says, you know what? Something pyrogenic has stimulated, or the immune system has recognized something that should not be here, a bacteria or a viral infection, and says, something's not right here. We're gonna call the army together. We're gonna get those heat shock proteins, FOXO3 proteins, immune cells, leukocytes, macrophages. We're gonna get them out. All right. So the hypothalamus says, now the new body temperature is maybe 37 Celsius is our body temperature. So they'll say it's 35. Sorry. So it'll say that it's, let's say, 40. All right. So the hypothalamus will say that now the new body temperature, now the appropriate body temperature is 40 degrees Celsius. So at first, 37 felt all right? It felt you are warm, you're fine. But now the hypothalamus said, now the new normal is 40 degrees Celsius. Now how do you feel? You feel cold. If you're supposed to be at 40 because your hypothalamus just said so, and you're at 37, you feel cold, right? That's the shivers. You ever had, when you're having the fever, you feel cold. And then your muscles are contracting. Why? To generate heat, to increase metabolism, to get you to that 40 degrees Celsius or 102 degrees Fahrenheit. So that's where you get those hot and cold flashes. So your hypothalamus, and it comes on all of a sudden. Why? Because your hypothalamus says, oh, something pyrogenic touched the hypothalamus. Actually, the hypothalamus is in the brain, but it actually has components below the blood-brain barrier. So it is in direct contact with the blood that is not in your brain, in the body. So it can see, oh, there's something pyrogenic, something that causes, something that's not supposed to be here. The hypothalamus says, let's stimulate a fever. objectively, just, not objectively, that's not the right word. It just resets the temperature to 40, and you get cold, you start shivering, you bring your temperature up to that high. That's the call to get the white blood cells into the immune system, or into the blood system, circulatory system. And then, of course, with heat, one of the intrinsic effects of heat is to increase metabolism. So those macrophages, those white blood cells, they're going to be increasing the rate at which they're able to do what they're supposed to do, because you're increasing the work. Just like when you put water over heat, the water molecules start to move faster and faster. Well, the macrophages start to move faster and faster, and they start to eat more. And so neat stuff. And we have the ability to augment all of these components, all of these mechanisms, just by external use of water. I wanted to put together a slide. Actually, to be honest, I put this slide together, this presentation together, last night. And so I didn't get to putting this aspect in. I wanted to make a slide that said all of the mechanisms that we talked about here, and say what we have a drug for and what we don't have a drug for. Okay, so antibiotics, right? Well, we're doing that here, but instead of taking an antibiotic, which kind of kills many of the white blood cells at the same time, as well as killing the bacteria, it does kill white blood cells at the same time. Well, we can do something that only stimulates the white blood cells. And not only that only stimulates the white blood cells, but helps the body to specifically attack only the problem via the heat shock proteins. All right? So that's cool. We have, I wanted to go more. Vasodilator, blood pressure medications. Well, we're increasing vascular compliance, the ability of the blood vessels to dilate and decrease blood pressure. I wish I put together that slide, because right now I'm not thinking of everything. But there's lots of mechanisms that we can augment just by using hydrotherapy, just by using water. So, any questions? Maybe we can, yeah. Sure. Mm-hmm.
What was your question again?
What would the difference be between the hot half bath and just a regular, like when I take a hot bath, I start sweating, so I start throwing water all over me. Mm-hmm. So I'm all wet, not just, up to my waist or whatever, and sitting there sweating it out. Yeah. So what would the difference be,
Absolutely.
if anything?
Yep, no. So you reminded me of a few other points, but I'll answer your question first. So the difference would just be in the amount of contact with the water. So instead of being up to here in water, so you have direct thermal contact with the water here. Now you're up to here. So you're just affecting vasodilation and body temperature a lot more intensely. You have more contact with the substance. So if I'm touching something that's hot here, okay, that's not too, but if I'm touching the whole thing, oh, that's more of an impact. Well, here we've got total contact with the water. Again, most of us don't have really nice deep pools like this one or a hot tub. You can just, and I'm small, so I can actually fit almost all the way under in my small bathtub. But if you can't, you can get a towel and just get that towel wet, and then place it over your chest and just kind of pour water over your chest, and that'll keep it warm as well. And again, this is one thing that she reminded me of. When you're doing these treatments, if you're going to put yourself in a hot bath, I would advise you to have somebody else with you, just so you don't faint or hyperventilate or something like that, or just do a nice neutral bath. Don't try to go really extreme. But while you're doing this, keep cold nearby to keep your head cool. Because we know that brain cells are actually a little bit more sensitive to thermal extremes. About 107 degrees Fahrenheit will actually start to kill brain cells. So we want to keep the head cool. And actually that is precisely the reason why physicians typically prescribe antipyretics, which are just pyro. What does pyro mean, right? Fire. So anti-fire, antipyretics. They prescribe antipyretics for a fever because they don't want the child to get a fever that's too extreme and get a fever that goes higher than 105 and then start to mess with the brain. So it's good. However, I'd rather educate people on how to work with the fever, because the fever, that's what the body's trying to do. So if you were to just keep the head cool, nice and cool, then you can let the fever run its course, or do an artificial fever. So just remember, keep the head cool.
I have 2 questions. The first one is, what temperature would kill cancer cells?
Good question. So in Europe, they actually have clinics that use hydrotherapy for the treatment of cancer. Wow. But in America, we don't really have that as much, and you're actually really not even supposed to say in America, like it's not the politically correct medical thing to say that heat can kill cancer. However, the mechanism here, this study portrayed, said that it can. Okay, so I'm going to let the study speak for itself and say the mechanism shows that it can. However, do we have clinical studies that show that the thermal does specifically kill cancer? Not so many. However, in our experience in Wildwood, Uchee Pines, Wannemacher, clinical experience shows that it does help significantly. So to get a specific temperature, I don't have a specific temperature, but what I do know is to stimulate the mechanism by which it works is about 100, like fever temperature, 102, 104 degrees Fahrenheit. So that would be my best answer, just staying to the science.
Okay, and then the next question is, for adhesions, would it be best to use massage or fomentations, or both? And if both, which one first?
Yeah, excellent question. So fascial adhesions, what those are is just fascia has got a nice grid work metrics, and when something is either when it's penetrated, broken, or you're in a certain position for a long time, that fascia will begin to bind and stick to each other, causing little adhesions. And so imagine it like right here. So right now my shirt can kind of move nice and easily. Well, this is an adhesion right here. Now all this fabric is, and I can't move so well. So she's asking, how can I reduce this adhesion, this fascial adhesion? Well, fascia is thixotropic, that nice physics term, which means when energy is applied, it becomes less viscous and more like water. So we can apply some heat to this area that warms it up, loosens up the fascia, and then we can do some stretching or massage and lengthen that fascia, right? So I would say a fomentation, or you can sit in a hot tub, or anything that applies thermal energy to that area, and then stretch it and lengthen it. And then so you can actually apply a fomentation and bring that motion, bring that arm or whatever it is through its range of motion. And that'll be like the stretching. Thank you. Any questions for Adan as well? Adan. This guy is a brilliant guy. He just reads all day. I don't understand how he does it. He's just okay, yeah. Amanda.
Oh, wait.
Oh, I'm sorry. Sorry.
Just to make sure here, is there any contraindication for hydrotherapy? The neuropathy issue for hot water especially, I guess.
Yeah. Adan, you're going to answer this one too. Did you hear the question? Yeah, contraindication. So I would say first off, the big one is neuropathy and any kind of sensation impairments. And then the next one is actually circulation impairment. So if someone has poor circulation to begin with, they're going to be less able to shunt blood flow away to carry the heat away. So remember I said that circulation, one of the things that it does is it helps to dissipate heat. So it helps to let heat off the body. Well, if we cannot dilate the blood vessels and cause, the heat is coming into the hand, so the blood vessels dilate, circulation, then that heat heats up the blood in the hand, or in these vasculature here, and then circulation brings it away. So you're actually dissipating the heat. But if you have impaired circulation, you can't do as well as dispersing the heat, and so you burn that hand a lot faster. Now you're like, oh no, but you just said it helps increase circulation. So this is where you just got to be careful. You just have to not as high of an extreme. So like neuropathy, one of the best things you can do is obviously help with the diet, but is do circulation, but it's a contraindication. Well, you just got to take it easy, go lower than you would. And someone with a circulatory issue, you just got to take it easy. And certain other cardiac, if they have cardiac impairment, obviously these studies showed that it was beneficial. However, these studies were done in a hospital, in a clinical setting, so they were prepared for any adverse effects if they were to happen. So I would just say, do it easy. Don't try to, yeah.
Yeah, one of the contraindications, what Josiah was saying about why we should not use heat for persons with diabetes is because they have compromised already their circulation. And Josiah mentioned that when you are applying heat, you are increasing the metabolism. But when you are increasing the metabolism, you are increasing also the demand of oxygen. And if you are compromising the oxygen demand because you have a bad circulation, because you have these high levels of blood glucose, you don't have enough oxygen, and you are going to turn into anaerobic metabolism without oxygen. And when you are using this kind of process of metabolism without oxygen, you are going to produce lactic acid, and lactic acid is going to damage some proteins in your muscles or in that area, and that kind of proteins, they are going to promote damage in the tissue. So that's the problem with myocardial infarctions, right? You have a blockage in the artery, so you are not having enough oxygen into that area. You are producing lactic acid, and this lactic acid overload is going to promote the damage of these kind of proteins, and that's going to promote necrotic tissue. So we have to be careful in using heat in persons with diabetes. Why? Because increase the metabolism. If you increase the metabolism, you don't have oxygen demand enough for this area of the body. So some contraindication for heat, when you are using heat, is just diabetes or diabetic neuropathy, right? Probably if you are going to go to the sauna, that we were talking to the sauna last night, a little bit, just be careful with if you have low levels of blood pressure, right? It can cause even yes, you can faint, or you can have very low levels of blood pressure during that applying heat. Yeah.
So stemming right from that, orthostatic hypotension is when you're laying down and you're fine, but then you stand up. The blood is all down in your lower extremities, right? And the heart needs to pump it up to the brain. But before it pumps it up to the brain, you pass out or you faint. So again, if you're doing this, be careful with getting up. Get up slowly. Apply your cold. That's another reason why we apply cold after, especially when we're going to do a whole body treatment, because we've just dilated all the blood. And as we learn, the blood vessels in our dermis can hold 25 to 35% of total blood volume. That's a lot of blood. That's not in our brain, you know. So we want to constrict those blood vessels, get it back to the organs so that it get to our brain, so we don't faint and then fall and break a pelvis, break a bone. So end in cold and just get up slowly.
As Josiah mentioned before, if you are going to further in doing the fever treatment of hyperthermia bad, try to be with someone with you, because you have to pay attention to your heart rate.
Yeah, your pulse.
Your pulse rate. As soon as you are creating this vasodilation, the heart starts to what?
Pump
pumping fast and faster, right? So you need to be careful with that, because if you have a person with problems already having a cardiac problems, well, you can develop even arrhythmias. You can develop even atrial or atrial fibrillation. So just be careful with that. You can do it, but try to be with someone. In the lifestyle center, we have some situations when we have been applying for prostate cancer this fever treatment, and I remember that one of our guests, he developed arrhythmias after the fever treatments. However, he was having already cardiac problems. Okay, so just when I say cardiac problems, well, I'd say, well, probably stents or any other angioplasty, right? Or recent coronary artery blockage or heart attacks, right? So just be careful with, you need to maintain your heart rate in order. One of the things how you can maintain your heart rate in order is just to apply ice into your chest, right?
Mhm.
I mean, yeah, over your chest.
Yeah, and we work well together because I'm very optimistic and I like to share the positive things, and he likes to buffer that. And you're like, whoa. But I will say that this is not the norm. So we do have we have occasions where somebody doesn't, but by and large, it's not the norm.
Do
But
it,
Be
yes,
careful.
please do
Yeah.
it. Just
Don't
be
say,
careful.
oh well, there's a potential, so I'm not going to do it. No,
Yeah.
do it. Yeah. Okay. There was something else I was going to say, but maybe you'll trigger it.
Would it be reasonable to extrapolate the benefits of all that we've talked about with circulation and tissue repair to something like abdominal fascial repair that is causing a hernia?
Okay, so would it be beneficial for a hernia, essentially, is what you're saying. So a hernia is just some part of the intestine or something inside of the intestinal cavity starting to bulge through a weakened area of a muscle or a ligament. So that's what a hernia is, just a weakened muscle or weakened fascia, just bulging through. And what typically is done is somebody will wear a little pad or diaper, kind of, what is it? What?
A mesh.
Yeah, just to kind of hold that in, and give time for a scar tissue to kind of form and the fascia to heal over it. And so now you're asking, would it be beneficial to help reduce that scar tissue that's formed to repair it, or what did you?
Help aid the body in repairing that tear to begin with.
Yeah. You know, I can't say that I know of a study that specifically shows that, but like you said, knowing all the mechanisms, I don't see why it wouldn't help. Yeah. Yeah, no, I definitely, I can't think of an exact mechanism, but I know it's definitely going to help.
It's gonna help with the pain.
Oh, yeah,
However,
sure.
it's not going to repair that damage in the fascia or in the muscle. So that's only with surgery, unfortunately.
Mm-hmm.
So, but yeah, you can do something with it.
You were talking earlier about the red meat, eating the red meat, producing chemicals in the body to digest it, or because they did a presentation at camp meeting, I don't know, 15, 16 years ago, a doctor from New Mexico talking about the eating of meat, that your body has to produce something that's actually destructive to itself to digest the meat. Is it the same thing that you were talking about or not? Because you're talking about the chemical compounds that's
Well-
created from eating red meat.
Well, there are many chemicals,
Yeah.
compounds that you are going to be getting from red meat. One of them, well, I spoke about the L-carnitine. It's going to be converted in TMAO. You will have a high levels of iron, which is going to promote the viscosity of your blood. You will have arachidonic acid, which is going to promote the inflammatory response as well. You will have high levels of uric acid, which is going to promote gout and also the viscosity of your blood as well. So there are many toxins that you will get from red meat. It's not just the TMAO or arachidonic acid.
Is it just red meat or is it all flesh foods? Because that's what the presentation was, because somebody was asking the question, what about eating fish? Is that bad for you? And the answer
Yeah.
that he was saying, yes, because your body's creating like a bile or
At
something to help
yeah,
produce
at this point, I can tell you that red meat, it's cleaner or it's better than fish.
Yeah.
You will have like 8%, no, sorry, 19% to develop diabetes or hypertension during a week if you are eating red meat every day. But every time that you are eating fish, you are increasing the risk of develop this kind of disease related with inflammation up to 8%. So if you are eating fish every day, it's going to increase the numbers up to 40%, right? So as I mentioned before, in order to convert this compound that I mentioned, like a TMAO, in red meat, you need a bacteria in order to produce that compound. In fish, you have it already there. You have it there. For persons with ladies in pregnancy, the FDA banned it. Don't use fish in pregnancy. Why? Because it can promote preeclampsia, which is the elevation of the blood pressure during the pregnancy, right? So at this point, mercury, lithium and some other heavy metals. They are related with fish. So it's not just red meat. I spoke about arachidonic acid, right? Chicken and eggs, they have the highest rate in arachidonic acid, not red meat. So it's not just red meat, it's chicken and any kind of animal meat. At this point, I cannot tell you, right? I mean,
Yeah. I don't know the specific enzyme or component that the doctor from New Mexico was speaking of, but he listed several, so it's probably one of those. But also, Dr. T. Colin Campbell, you've probably heard the name, the author of the China study. He really took a deep dive into this and just looked at animal protein and its effect on cancer. And dairy protein and animal protein in general, but dairy proteins, yeah.
Dairy
So
proteins.
yeah.
Dairy proteins. We spoke the last night about the IGF-1, the insulin growth factor one, right? That is related with cancer, increasing or proliferate the cancer cells.
Mm-hmm. Okay.
Oh,
Let's go here.
yeah, I was just wondering if for all the things that you've been talking about yesterday and today, if you can recommend books or resources or things, and also if any of them would include stuff on food, like we asked, I think it may have just been us here before we started today, about the difference between like what foods or vegetables should be cooked in order to help with the enzyme breakdown and all that versus what should be eaten fresh and all that, like books and resources for that kind of stuff.
Yeah.
Well, you can.
Okay.
Yeah.
Okay. So where you can go, a couple of places, as he mentioned, probably last night and this morning, you can go to what's the place? Uchee Pine's website, and they have a lot of good information on specific treatments and protocols. That's cool. So keep that, Uchee Pine's website. Also, another good place to go that I really like and I like sending people to is nutritionfacts.org. Look at that, nutritionfacts.org. Dr. Michael Greger really looks at all the nutrition research that comes out each year, him and a team, and they analyze it, and they produce easy to understand and digestible, pun intended, videos that help you to make good lifestyle, more dietary choices. Now, in reference to enzymes and cooking and not cooking foods and soaking certain grains and soaking nuts and stuff, I haven't found a good one source for that. I know, like for garlic, to get the anticoagulatory aspects of garlic, you eat it raw, and if you don't want those, you can steam it. Or lycopene, you get more lycopene in cooked tomatoes than you do in raw tomatoes. But a good source there to find more of information like that, I don't know. I've just found it here in different studies here and there.
For that specific question, I am not sure either. I mean, what could be the best website? However, there is, besides nutritionfacts.org, you can get also into lifeextensionmagazine.com. You will have many protocols in order. You will have biochemical pathway. You will have supplements also. There's another website. It's called.
Could you say that last one again?
Life Extensive Magazine. Sorry, Life Extension Magazine.
Yeah.
Life Extension Magazine. The other website that you can go as well, it's from Andrew Will. AndrewWill.com. He is one of the best physicians in the University of Arizona. Andrew Will, W-E-I-L-L.
Wheel.
Maryland, University of Maryland, they have a good resource as well into, if you want to know more about herbs. They have a very good resources in order to check some herbs and some conditions as well.
Another book I strongly recommend is, again, by Dr. Michael Greger, How Not to Die. That's a good book. Very, very study rich. So How Not to Die. Very applicable to all of us.
And he has a new book that just got released, How Not to
To
Diet.
diet. Yeah, another good one. I don't have it. I just know that it's good.
Specific about obesity, right? Well, in terms of books, I mean, there are plenty.
Yeah.
The Longevity Diet, Walter Longo.
Oh, yeah.
Mind Over Maths by Andrew Will. The two main ones that I really recommend to you is the Diabetes Code. Diabetes Code and the Obesity Code by Jason Funk. They are very two books where I have been learning a lot from it. From those books, The Longevity Diet, Walter Longo as well. Plenty of books.
If
right?
if you go to those places, it'll take you to another place, and yeah, it'll be a nice
However,
spider
yes,
web.
I mean, those kind of books, they talk about science, and they are good sources of information, right? But many of our presentations, we have a filter.
Yeah.
And the filter is Ministry of Healing,
Mm-hmm.
Councils on Food and Diet, and the Ellen G. White writings. I don't use anything that is not related with the health message. And honestly, I have been very blessed reading the Ministry of Healing and reading the Councils of Food and Diet. And there's another one. It's called the Mind, Character, and Personality.
Mhm.
If you want to create good habits, if you want to have emotional intelligence, that is a boom right now. Everybody's talking about emotional intelligence. Well, Ellen White mentions that. Not like emotional intelligence, but with some other words, right? Mind, character, and personality. There's 2 volumes about it.
It's really neat to see that we have an incredible privilege. It doesn't matter how you feel about Spirit of Prophecy. I think it's an incredible blessing, and I've been blessed by it. However, people have been looking back at what Ellen White was saying in her day, all the health claims that she was making, and a lot of people were making health claims in that time period. Like, this is good. A physician would say, this is good, and this is good, and this is good. And maybe 2 things that this physician actually turned out that he said may have been well out of the 100 things that he said. He said to drink arsenic and do this and do all these other things. And maybe somebody over here said some things that were good, and he said other things that were not good. And that science started to find out, oh, this is not good. But 100% of everything Ellen White said has been true. Everything that we have come to understand has been accurate. It's like, wow, that's really interesting. That's a perfect track record, you know? So if some things that she said, science has not quite caught up with, but if we know that every time before she's been right, statistically, she's probably going to be right again. So it's an awesome filter, as he said. Just, does this align with Spirit of Prophecy?
Jasmine and then Elaine.
Can you speak a little bit about why we should or should not use apple cider vinegar?
Mm-hmm.
Interesting, apple cider vinegar. I have been in situations where the apple cider vinegar, it can decrease the blood pressure. Also, it's in the book, The How Not to Diet, Michael Greger mentioned to use apple cider vinegar to for reduced weight or for lost weight or weight loss. However, if we can check in the studies for animals laboratories, in order to produce gastritis, in order to produce gastric acid reflux, in order to produce this kind of tumors and cancer in the stomach,
Just
they induced
vinegar.
these kind of conditions with any kind of vinegar. So this is one of the things that is telling me, well, probably it can decrease your blood pressure, it can help you to lose weight. However, there are some side effects from it, right? It's the same situation with the hydrogen peroxide, right? Many people is using now hydrogen peroxide. And hydrogen peroxide, well, it can increase the levels of oxygen in your body. Even, I learned just that if you want to grow faster and better plants or any kind of plants that you are planting, you can put hydrogen peroxide in the soil in order to promote this, enhance it, the oxygen, in order to have more nutrients in the plants, right? However, when you have a high levels of hydrogen peroxide in your body, because you are producing hydrogen peroxide, and also because you are drinking hydrogen peroxide, well, it's going to cause a damage in your tissue, right? So we have another compound as well, well, the hydrogen peroxide, alcohol. You need alcohol, or I need alcohol, we need alcohol. However, your body produces alcohol. But when you overload the amount of alcohol, there are certain enzymes that they cannot counteract the poisoning effect of the alcohol. It's the same with vinegar. I mean, we cannot overload these mechanisms when certain enzymes, they are not able to break down these compounds. And when we are not able to break down these compounds because they are overloaded, they are going to cause a harm instead of a benefit, right? So that's a problem with apple cider vinegar.
Another thing maybe that you kind of said, but just make it a little bit more amplified. Apple cider vinegar is acidic, so when we consume that acidic food, it's increasing the acidity in our stomach, and things that are acidic burn. However, in our stomach we have a membrane, the mucosal membrane, which helps to buffer that acidity, because the pH in our stomach is very low to act as to kill pathogens, to kill bacteria, to act as that initial buffer. Okay, but when we add that acidity, it tends, what actually happens is we start to actually decrease the amount that our proton pumps are producing protons, and the protons are what create a low pH. So we actually, the body starts not producing as much hydrochloric acid, or the substance that create that low pH. And so what happens is, maybe if you drink apple cider vinegar regularly, and then the times that you don't, you have a higher pH, so more opportunity, so food's not being as well digested. Pathogens are able to get in and through the stomach and into the intestine more easily because it's not as low of a pH. So you have something that lowers the pH, and then you take that away, the mechanism that we had previously to secrete and lower that pH is now not working as well, because, why would we need to? This guy is just always consuming something that's very acidic, so why do we need to produce something acidic? So it leaves room for that way as well, but predominantly for the reasons he said. Yeah. All right.
Okay, so for the last month, I've been using warm lemon water in the morning with a couple of shakes of cayenne pepper in it for blood pressure and inflammation.
Mm-hmm.
And I've seen some improvement, but I was wondering, how long would you continue to do that? Like is it just like teeny bit by teeny bit by teeny bit until it's gone? Or what? And also focusing on foods. I mean, I've been vegetarian for 24 years, vegan on and off, but I'm on forever now, that. And not only that, but whole foods, like very little processed
Absolutely.
foods, and just focusing on whole plant foods. So with that and my lemon juice cayenne regimen,
Sure.
how long do you think I can?
So answer the first thing. Lemon juice has been really shown, not lemon juice from pre-made bottled, but lemon from squeezed lemon has been shown to be beneficial in helping to lower blood sugar levels. And he'll touch on the cayenne. But any shift we can make to eating foods how they were originally made, how they were originally grown, will be better. So the least processing you can do, or the processing that you do, let it be your own processing. So actually cooking the beans yourself instead of buying them in a can. Anything you can do will be much more beneficial. So it's all about shifting more towards a better lifestyle. So eating better, having a better lifestyle, exercising, doing some hydrotherapy. Obviously, I wouldn't advise just trying to treat diabetes with that hot tub.
Well, I don't have diabetes. I mean, I'm not diabetic, but it's the blood pressure thing for me, and the need to increase activity and stuff.
So
but
everything will be beneficial.
But I'm
now
kind of
specific-
impatient when it comes to, like, when's it gonna be all healed?
Well, the
Actually,
idea.
Can I say one more thing?
Yeah.
As far as the blood pressure, if that's why you're taking the cayenne, and cayenne has been shown to have a vasodilatory effect. Actually, rabbit trail. One thing that you can do, someone who's having a heart attack, I've heard several people say this, but if someone's having a heart attack, what they've found is I've heard many stories. People carry cayenne and they throw cayenne in the person's mouth that's having a heart attack, and it acts like a vasodilatory effect, and it's prevented them from having a heart attack or dying from it. There was one story that I know, somebody in an airplane saw someone who was having a heart attack. They're in the airplane, they're in the air, so there's nothing else. He got his cayenne, threw it in his mouth, and again, you can't say, there's always the person that's going to say, well, he probably wasn't going to die anyway. But, so there is a mechanism there. But also, so we talked about vascular compliance in hydrotherapy. That's so we know that there's a vasodilatory effect when we go in the hot right at that moment. But what's happening there is you're actually stretching the blood vessel muscles, those smooth muscles. And we know if we want to have flexible skeletal muscles, we have to stretch to prevent injury, to prevent them from getting torn and stretch. Well, same is true with our vascular muscles. So you can think of hydrotherapy as vascular stretching or vascular gymnastics. And vascular compliance has to do with how well they stay stretched after your hydrotherapy application. Mm-hmm. And it turns out it has a longer lasting effect as well. So stretching those smooth muscles is going to be very beneficial as well. Now,
Well, the question was how long you're going to have some results, right?
mhm.
Yeah.
How long will it take?
It's going to take many supplements. For example, L-arginine. You can use it for
Cardiac
hypertension.
function, yeah.
Magnesium citrate. You can use it for hypertension. Celery juice. You can use it for hypertension. You mentioned lemon water with cayenne pepper for the reasons that Josiah mentioned. Many of our guests in the Lifestyle Center, we don't see results up to like 3 months after they have been using these items, right, or these natural remedies.
So I can expect that it's probably just gonna keep getting better little by little, because it's only been a month since I've been doing that.
Remember that natural remedies, they work better, but in a slow process and without side effects. Well, most of the time. Don't get discouraged. Don't get desperate. For example, the DASH diet. It's the dietary approach to stop hypertension. Well, they say that they are going to, they are seeing results up to after 3 months of adopting this diet. It is just vegetarian diet, but they are using fish. We are not using fish. So don't get discouraged. Continue using this, but at least 3 months you will have some results. We have some people, individuals that come into the Lifestyle Center and they want to reduce their blood pressure in only 17 days when they have been having blood pressure for 20, 25 years. So we cannot modulate these kind of conditions in 17 days or even a month. Many of them, they leave the Lifestyle Center and they exactly, yes, your exercise, sunshine, all the natural remedies, but they are going to take time in order to see results. So continue doing it. It's very good what you are doing it.
Yeah. One other thing that I was going to say before. Once we had a client or a patient, and he started to faint. He started to have extremely low blood pressure while he was eating. And so right then what we did is I took his blood pressure, I don't remember what it was, very low though, and I was like, uh-oh. So he just ran and got some cold water, put it down, put his feet in the cold water, and then it brought his blood pressure up. And then after a while he was fine, he was cognitively functioned. That's how low it got. You asked him a question, he didn't know what was going on, nothing. And so put his feet in cold water, came up, and when we took his feet out of the water, he was fine after that. And then for the opposite, someone who had really high blood pressure, put his feet in warm water. And that decreased, obviously, we have an immediate physiologic effect, but then because of that vascular compliance and everything kind of evened out and no longer had that acute situation. So
that compliance that Josiah is talking, there is that elasticity, elasticity of your blood vessels.
Do you have any natural suggestions for hyperthyroidism?
For
Hyperthyroidism.
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 One of the things that it can help you for hyperthyroidism is the hot and cold fermentations. For hyperthyroidism, hot and cold fermentations, okay?
Cold?
Hot and cold.
Okay.
These are revulsive or contrast effects, right? Some others that I have been seeing in order to treat hyperthyroidism is going to the sauna as well. It can help you. However, many times you need to prevent the symptoms or the signs of hyperthyroidism. For example, tachycardia, right?
I don't have that. I had an ablation in 2014, so I don't have that. I do have some palpitations,
Yeah,
But not-
palpitations. yeah.
not tachycardia anymore.
So there's some herbs that they can that they can use for tachycardia, right? If you can get online for any thyroid support,
What is that again?
thyroid support. Iodine, it can cause also hyperthyroidism and hypothyroidism at the same time. We know that when you are having this kind of issue of hyperthyroidism, in many situations you need to take the medication in order to the metamizole. I don't know if you were taking that medication, metamizole.
No.
Okay.
I've been using iodine
Okay, well,
to decrease.
kelp can help as well.
Mm-hmm.
So there is not many, as far as I know, there is not many natural remedies for hyperthyroidism.
Okay. Thanks.
I was just wondering if you could talk a little bit about hypothyroidism and if there are remedies for that.
Yeah, hypothyroidism is a little bit easier to deal with. So what's happening is the thyroid is not producing enough thyroid stimulant or T3 or T4 tetrathyroxine. Yeah. Anyway, and so there's a number of things that you can do to increase that. Since I was just talking about hydrotherapy, I'll start with that one. So what you can do is create an environment where your body has to work. So your thyroid regulates metabolism largely. So if someone has we call it slow metabolism, they don't burn energy very well. So this would be hypothyroid. And hyperthyroid are typically people a little thinner and they're just always burning. Their metabolism is always running, kind of. That's how we usually think about it. So if what we found is, or what hydrotherapy has shown, is that when we can put somebody in an environment which forces them to actually have to increase their metabolism on their own. So when we apply heat, that's externally increasing metabolism, right? Every degree Celsius is a 10 to 12.5%, according to that study, increase in metabolism. That's external. But if we can create an environment where the body has to generate heat, that's metabolism. To generate heat, you need to do metabolism. Then it tends to force the thyroid to have to function better and a little bit more quickly. And yeah, so doing a wet sheet pack, we didn't talk about this one, but this has been found really beneficial for people with hypothyroid, where you take a big sheet, you get that wet, like a twin-size sheet or a queen-size sheet, you get it wet, you wring it out, you put it in the freezer, and then you take it out, and it's cold, okay? And he knows where I'm going with this, okay? And then you wrap the client or the patient in that sheet, and then you wrap them around a warm, comforter type thing to insulate it. And so the body is in that cold initially. It's like, whoa, that's cold. But then the body realizes this is not a life or death situation. So I don't just need to protect the vital organs. Let me shunt the blood out to the skin to reheat the skin. Well, that takes work. That takes energy for the body to do that. That takes the thyroid to stimulate metabolism. So you're forcing the thyroid to function and to work. So that's been really found to show improvements in thyroid function in as far as increasing the amount of T3, T4 production, as well as in consuming iodine. And you don't need to just do the wet sheet pack. You can also go in a cold tub, go in a cold shower. That's very stimulating. So iodine is a good one.
Kelp, seaweed, you can use it also for hypothyroidism. And Josiah mentioned, the idea is to increase the metabolism. Okay, that's the idea.
But not from an external source. You want to make the
I
body.
mean, yes, I mean from your body as well, right? Yeah. You can use a thyroid support, which contains, of course, iodine, seaweed, kelp, and also some other herbs like ashwagandha.
When you say thyroid support, that's like a supplement.
It's a supplement. Yeah, thyroid support is a supplement. If you go into the website of ugpints.org, you will have a handout for hypothyroidism. And there are some cruciferous or vegetables, right? They can suppress the production of your thyroid hormones. So you need to pay attention of those, right? I don't remember, I don't have it in my mind, what are the vegetables or cruciferous that they can suppress. So you need to avoid those as well for hyperthyroidism as well, right? Oh, okay. Thank you. So you need kind of like to avoid this kind of items, right? But get a thyroid support. There's a very nice thyroid support. It's a supplement by, I'm going to mention the brand, it's Gaia, or you can use any other brand, but is one of the supplements that I have been seeing with a good results with persons with hypothyroidism. And of course, everything what Josiah mentioned, right?
What do you think about the use of supplements like vitamin D, B12, calcium, magnesium? And calcium, if you take that, can you get calcium deposits from that? Or if you don't have enough calcium, can you get calcium deposits?
Yeah. Hey, I'll say something general, and he will, in all his infinite wisdom, will say something more specific. But we have to be careful with fat-soluble vitamins, just because we can store those in our body. So we have fat-soluble vitamins and water-soluble vitamins. Vitamin C is a water-soluble vitamin, so we intake it, and if we have too much, we just nicely excrete it through our urine, and we can get rid of it pretty easily. But fat-soluble vitamins, we don't get rid of very well. We actually just store them in our liver or other areas, and we can get supplement toxicity, or whatever the supplement that you're taking, you can get that toxicity. So you really want to be careful with taking supplements, especially fat-soluble supplements. And as far as, you just said calcium, and that triggered something in my mind. In order to absorb calcium from the intestine, you actually need vitamin D. So if you don't have good vitamin D levels, you're not going to be able to absorb calcium. And so what happens is the ultraviolet light comes and synthesizes the cholesterol in our dermis and causes that to become cholecalciferol. And then that cholecalciferol goes to your kidneys and produces calcitriol. And then that calcitriol from your kidneys goes to your intestine. And that is what enables the absorption of calcium. So if people are saying, "Oh yeah, I'm taking calcium. I'm drinking my milk even," well, that's just ludicrous for calcium. Anyway, but I'm taking calcium. I'm eating calcium-rich foods and all this. But if you don't have good vitamin D levels or calcitriol, it makes no difference. So having a whole approach is definitely good. Now,
what supplements, if you are vegetarian, what supplements do you need? Probably you will need vitamin B complex, for sure. Vitamin D if you are not sufficient time outside. However, I would prefer to recommend to you going to do a sunbathing instead of using supplements. You never should be using calcium for the reason that you said, right? Calcifications, overload of calcium, and the reason is not low amounts of calcium, but it's low amounts of vitamin D, and you are not absorbing the calcium, right? Vitamin E is related also, it's linked with lung cancer. Vitamin E, that's why I mentioned before, well, you don't use supplements of vitamin E, which is anti-inflammatory. However, you should eat nuts, almonds, avocados, that they contain good levels of vitamin E. You can get magnesium. No, I haven't seen many problems with magnesium, and you can get magnesium. Don't overload the amount, no more than 400 milligrams of magnesium a day. It's a very good supplement in order to prevent muscle cramps, to stabilize also your blood pressure, and also to reduce stress response as well. What other supplement do you need?